Hi guys, welcome back to Worms Maths Academy. Today we're going to be looking at sketching parabolas, then also looking at the completing a square and um, the discriminant, well, the start of the discriminant. Okay, so the first thing, the basic form of a parabolic graph is given by this. So, well, actually the most basic form is y equals ax squared. Well, we could just say x squared. So x squared is just a parabola at the origin, no dilations, translations, etc. This graph here, this causes a dilation factor a from the x-axis. Now if a is greater than 1, well then the graph will become skinnier. If it's between 0 and 1, then it will become wider. And if it's negative, then it will turn it upside down. So A determines the shape of the graph. It can turn it upside down if it's negative, and it can make it skinnier or fatter. It actually changes the shape of the graph. Whereas H and K, they're what we called translations. And translations, they move the graph left and right in terms of H. So if it's minus H, we go right H. If it's plus H, we go left H, like whatever H is. And if it's plus K, we go up K. If it's minus K, we go down K. So from that, we can always say that our turning point is HK. That's because it's been moved K to the right, and H to the right, and K up. Okay, and I've said all that stuff here. Dilation changes the shape of the graph. H determines the translation left or right. K determines it up or down. The turning point HK, and the axis of symmetry is x equals h. The axis of symmetry is where the graph is symmetrical about. So here, that there, it's the middle of the graph, and we can see that side and that side are symmetrical. It's a mirror image. So the x value of the turning point is where it's symmetrical. Okay, so if we look at this first graph, we know that that is a translation left 2 units, or you could say 2 units in the negative x direction, and because it's also a translation, 1 unit in the positive y direction. So if it's 2 units in the negative x direction, and then 1 unit up, there's our point. It hasn't been dilated, so we know it's going to go through a point 1 to the right and 1 to the left, and then also a point 2 to the right, and then 4 up, so it's going to go through 0, 5, and negative 4, 5, and it will look like that. 0, 5, and we know the turning point is negative 2, 5. You might ask, how did I know that it's going to go through those points? Well, a basic parabola goes through 0, 0, then 1, 1, then 2, 4. So if it hasn't been dilated, it's got exactly the same shape. So we know we can go across 1 and up 1, we can go across 2 and up 4. We could go across 3 and up 9, because we know that this one goes through 3, 9. That allows us, because we know it's got no dilation, it's got a dilation of 1, so it hasn't been changed shape. It makes it easy to put points on the graph. Okay, this one here, well, it's been dilated factor 3 from the x-axis. Now, a standard graph would go through 0, 1, 1, 2, 4. We just worked that one out. However, this graph has been multiplied by 3 from the x-axis. So it'll still go through 0, but it'll go through 1, 3, and then it would go through 2, and it would be 12 because it's been multiplied by 3, so it's much skinnier. Then we've got to take into account the fact that it's been translated right, or 1 unit, in the positive x direction, and 4 units in the negative y direction. Okay, so if we do that, it's got the same shape, but it's been moved 1 to the right, down 4, so it's going to go through there. Now we know, because it's been dilated by factor 3, if we go across 1, we're going to go up 3. If we go across negative 1, we're going to go up 3. And my graph is going to have the same sort of shape as the blue graph. Now, if you want your x-intercepts, well, you just solve it. You let if we let y equals 0, we get 3 x, pen's playing funny buggers, minus 1 squared minus 4 equals 0. So from here we get x minus 1 squared is equal to 4 on 3. X minus 1 is equal to plus or minus 2 on 3, the square root of 3. Because if I square at the top I get 2. If I square at the bottom I get root 3. I'm going to rationalise that. So I get 2 root 3 on 3. Okay, so then we get x is 1 plus or minus 2 root 3 on 3. 1 plus 2 root 3 is going to be this point. And then 1 minus 2 root 3 on 3. That's going to be that point there. Okay, our next one, let's change to a purpley colour. It's been moved 1 to the right and 2 down. Actually, it's been reflected first, so it's turned upside down. It's been moved 1 to the right and then 2 up. So there's my point. We know it hasn't been dilated, so we move across 1 and down 1, across 2 and down 4, and down 4. So there's my graph. My turning point is 1, 2. My x-intercepts, if we let y equals 0, we get minus x minus 1 squared is equal to plus 2 equals 0. Bring your x minus 1 to the other side. X minus 1 squared equals 2. X minus 1 is plus or minus root 2. X equals 1 plus or minus root 2. So we'll say that's 1 plus root 2, 0, and that's 1 minus root 2, 0. So there's a couple of our basic quadratic graphs. Okay, this graph here, by completing the square, write the quadratic that in the turning point form and hence sketch the graph. Okay, so let's start. We've got f of x. We know we've got to take out negative 2 because whenever you complete the square the coefficient of x has to be 1. So negative 2 x squared. If I've taken a negative 2 out of that, that'll be minus 2x. If I halve that I get negative 1, and when I square it I get positive 1. Now I haven't added positive 1 on, I've subtracted 2 because negative 2 times 1 is negative 2. So I've got to add 2 on so that I don't change the equation. And then I've got that plus 3 that was already there. So from here, negative 2 x minus a half of that value, 1 all squared, those two things are the same. And then I've got plus 5. So my turning point is 1, 5. It's inverted because it's negative. and skinnier. So if we go across 1 and up 5, we know if we go 1 this way, we've got to go down 2, and same down 2 because it's been dilated factor 2 from the x-axis. And if we go across 2, I've got to go down 8. So 1, 2, you get close and it starts writing. 1, 2, 3, 4, 5, 6, 7, 8. And then there. Okay, so that's our graph. We know our turning point is 1, 5. If we let x equal 0, we've already got our y-intercept, it's 3 from that. 3. So we know that's 0, 3. And we know that is 2, 3. To find our y-intercept, just going to move this out of the way. Okay. So we've got, if we let y equal 0, we get negative 2x minus 1 squared plus 5 is 0. Bring your 5 to the other side and divide it by negative 2. So x minus 1 squared is equal to 5 on 2. X minus 1 is equal to plus or minus root 5 on 2, which is equal to, if we've got root 5 on root 2, if I times it by root 2 on root 2, I get root 10 on 2. So we get 1 plus or minus root 10 on 2. So that'll be 1 plus root 10 on 2. And what do I just do? On 2. 0. And that'll be 1 minus root 10 on 2, 0. So there's all of our points that we need to know. Now, oh, why is that rotated? Let's go back. Okay, so zoom, initialize. Okay, so any of those graphs we could just graph in here. So this graph here, negative 2x squared plus 4x plus 3. Sketch it. There it is. Our turning point is 1, 5. If you want to put it into turning point form, you need to go into conics, which is here. Then you do y equals, and then paste the equation. So your equation's there. Now you click on this, it means convert. And we want to convert it to being this form, because it's a turning point. Click OK. Negative 2x minus 1 squared plus 5, which is exactly what we got. Which was that. Oh, that one there, sorry. You can sketch it, so you can see that's where it is. If we wanted to solve it, we could just grab this, edit copy, go out into the main, paste, equals 0, make sure it's in standard because you want exact answers, interactive, advanced, and solve, and we get negative root 2 on 10 plus 2, negative root 10 on 2, negative root 10 on 2 plus 1, negative root 10 on 2, minus that, we get exactly the same thing we got before. Okay, on this calculator, if we put in the calculator, we get negative 2x squared plus 4x plus 3. If we set it equal to 0, this one we should have done first. Menu 3.1, solve. If you go Control A, you can highlight it and then go menu 3.1. Oh, what just happened then? Escape. Menu. I don't want that graph. Let's see, view. No, we don't want any of that. Graph. I don't know how I put that there. Okay, go back, escape, escape. Somehow I did that. Okay, I'm going to add a new one, so plus page, Come on, you can do it. Okay, so negative 2x squared plus 4x, and then plus 3 equals 0. Control A, menu, 3, algebra, 1, solve. Now you've got to put comma x at the end of this. I don't know why it doesn't just default to it. Comma x. So there's our values. Let's put it over a common denominator. The other thing you can do, okay, I hate this calculator. Okay, negative, what do we want to do? If we want to sketch it, you can just go control page, add graph, negative 2x squared plus 3x, 4x, of course, I did it wrong, 4x plus 3. See, there's our sketch. The other thing I was going to tell you, if we add another page, you can go menu, 3 for algebra, 5 for complete the square, and then you just say negative 2x squared plus 4x plus 3, and then comma x. Sometimes it requires it, sometimes it doesn't, and that's it, completed the square. Okay, so you know how to graph on both calculators, you know how to find the turning point on both calculators, you know how to find the x-intercepts on both calculators. The axis of symmetry is the turning point. Now there's a few ways you can find the turning point that you know of now. The first one is to complete the square. That'll give you the turning point. The x value of the turning point is always negative b on 2a, where y equals ax squared plus bx plus c. It's also halfway between intercepts. Okay, so for each of the following quadratics, use the axis of symmetry to determine the turning point of the graph. Express the function in the form y equals x minus h squared plus k, and hence find the maximum and minimum value on the range. Okay, so we know x is equal to negative b, so negative 6, on 2 times a, which is 1. So when x equals 3, we've got the turning point. When x equals 3, y is 9 minus 18 plus 3, which is negative 6. So then our turning point is 3, negative 6. So to put it in turning point form, x minus 3, because it's 3, opposite sign, minus 6. Hence find the maximum or minimum, so that's a min, and it's negative 6. And find the range. Well, the lowest value is negative 6, so you can say y is greater than or equal to negative 6. This one here, my x value is negative b on 2 times a, 2 times negative 2, negative 12 on negative 4, which is 3. Y is equal to negative 2 times 9 plus 12 times 3 plus 5. What did I do there? That was negative 2 times 9. So I get negative 18 and then plus 36 plus 5, which is 18 plus 5, 23. So we've got a max of 23. It's turned upside down, so we say the range is y is an element of negative infinity up until 23. Lastly, we've got to put into turning point form. So we've got because I've got a negative 2 at the front, that has to come out the front. So y equals negative 2 x minus 3 squared, and then plus 23. So that's it in turning point form. Okay, so here, find the x and y-intercepts on the turning point of this graph. So y equals x squared minus 2x minus 3. Let x equals 0, y equals negative 3. Let y equals 0, we get x squared minus 2x minus 3 is 0. X minus 3, x plus 1 is 0. X equals 3 or negative 1. So 3 or negative 1. We know that our halfway point is our turning point. When x equals 1, if we put it into here, y equals 1 squared minus 2 times 1 minus 3. So 1 minus 4 is minus 4. 1 minus 5 that was. So minus 4. Is that right? 1 minus 2 minus 3 minus 4. No, my y-intercept's negative 3. Look, it doesn't look right. Oh, neither does that. Okay, so we've got negative 1, 0, 3, 0, 0, negative 3, 1, negative 4. And that's our graph. Okay, this graph here, nice and easy. First thing we do, let x equals 0, y equals 0, so it's got to go through the origin. Let y equals 0, we get x minus 3 equals 0, so x equals 0 or minus 3, plus 3, sorry, 0 plus 3. We've got our x and y-intercept to find our turning point. We can complete the square, we can sub in the halfway point. X equals 3 on 2, y equals 3 on 2 squared, minus 3 times 3 on 2, 9 on 4, minus 9 on 2. If I put that on 4, I get 9 on 4 minus 18 on 4, which is minus 9 on 4, minus 2 1/4. So we've got 1 minus 2 1/4. So 1 minus 9 on 4. And then we've got 3, 0, and we've got 0, 0. So there's our graph. Okay, this one here, we know it's just a parabola that's been translated down 4. So it's going to go through negative 4. If we let y equal 0, we get x squared minus 4 equals 0. X plus 4, x minus 4 is equal to 0. That's x plus 2 and x minus 2. X plus 2, x minus 2. So x equals negative 2 or 2. So there's our graph. And then 0, negative 4. That's pretty much it. This one here, find the x and y-intercepts and the turning point. So if we let x equals 0, we get y equals 8. If we let y equals 0, we factorise, we get x minus 4, x minus 2, because negative 4 times negative 2 is plus 8, and negative 4 minus 2 is negative 6, 0, so I get x equals 4 or 2, so 2, 4, 8 is going to be somewhere up here. My turning point, x equals 3 because it's halfway between those two. Y equals 9. minus 6 threes are 18. Don't know why I rubbed that out. And then plus 8. So I've got 9 minus 18, negative 9 plus 8 is 1, negative 1, negative 1. So that is there. So we're going to have a graph that looks like that. 4, 0, 3, negative 1, 2, 0. There's our graph, turning point, etc. Doesn't specify a method, so we can just do it. Okay, quadratic inequalities. Usually it's as simple as factorizing or solving and then graphing. You have to graph. So here, if we factorize that, we get x minus 4, x plus 3 is greater than 0. When I sketch that, I get 4 and negative 3, and it's a positive parabola. Now I want to know when this graph is greater than 0. So there's 0, there's 0, it's greater than it there, it's greater than it there. So we say x is less than negative 3, that's here, or x is greater than 4, that's there. Okay, the next one's the same. Factorize 2x, x. If I put a 2 there and a 3 there, that's going to give me 4 and that's going to give me 3. And I want to end up with a negative x, so it's got to be negative 4 plus 3. That's less than 0. So if we sketch it, that's going to give me x is negative 3 on 2 and x is 2. So there's 2. Negative 3 on 2. Draw it, it's a happy face because it's a positive x squared. When is it less than 0? It's less than 0 from here to here because it's down here. So I say negative 3 on 2 is less than x, which is less than 2. Can't be equal because when it's equal to 0, it actually equals 0, but we only want less than 0. Okay, the quadratic formula. I showed my students last time I did this. Actually, you can complete the square and show how to get the solution to it. If you complete the square on this thing, you end up with the quadratic formula. What we want to do is label our values. A is 2, B is negative 5, C is 3, and then we just put it into that formula to get what our x values are, our x-intercepts, or our roots, you can call them roots. X is negative b, so 5 plus or minus the square root of negative 5 squared, 25. I don't know what I just did. Okay, 25 minus 4 times a, which is 2, times 3, all on 2a, so 2 times 2. We end up with 5 plus or minus 4 2s are 8, times 3 is 24. 25 minus 24 is 1. The square root of 1 is 1. On 4. So I get 6 on 4, which is 3 on 2. 3 on 2. Or I get 5 minus 1, which is 4 on 4, which is just 1. So they're my two solutions. So they're the exact values. This one here, a is 3, b is negative 7, c is 1, x is negative b, so plus 7, plus or minus the square root of 7 squared, or negative 7 squared, it's the same thing, 49, minus 4 times a, which is 3, times c, which is 1, on 2 times a, which is 6. So I get 7 plus or minus 49 minus 12, which is root 37, on 6. We can't do anything with that. That's it. This doesn't simplify. 1, it's a, what's the term for a, got a mental blank. It's only divisible by itself in 1, and that means that it is a prime number. So it can't simplify unless it's a perfect square, but then I wouldn't be prime. So yeah, it doesn't simplify. Okay, this one here, all we've got to do, A is 1, B is negative 3k, C is, because we've got to take the coefficient, C is 6, X is negative B, so 3k, plus or minus the square root of B squared, 9k squared, minus 4 times A, which is 1, times C, which is 6, all on 2A, which is just 2. So we get 2k plus or minus root 9k squared minus 24 on 2. That's our solution. Of course, you can put that into the calculator. It'll give you the same answer. So x squared minus 3kx, x squared minus 3kx. Piss off, you stupid thing. So if I do it in this, x squared minus, now when you put in 3k times x plus 6 equals 0, highlight, interactive advanced solve for x. Okay, that's just simplified it by taking out a common factor. Oh, that's a 3. My poor handwriting over there, stuff that went up. So I would just leave it the way we had it. You can take a 3 out of that, but it's kind of pointless. Okay, so this will be the last thing we do, looking at the discriminant. So our discriminant tells us, it's actually, if you think about negative b plus or minus the square root of b squared minus 4ac on 2a, it's the, what's under the square root? So if that's 0, then I just end up with one solution, which is negative b on 2a. Which, that makes sense. If it's less than 0, we can't square root negatives. So therefore there's no solution. If it's greater than 0, I'm going to have negative b plus or minus a value. If I have negative b plus a value and negative b minus a value, that's going to give me 2 solutions. And if it's a perfect square, well, it makes sense. If you've got the square root of a perfect square, that's just a whole number. So we end up with negative b plus or minus whole number, divided by 2a. So that's going to give us 2 fractional answers or 2 whole number answers. Just like we got before on the previous page here. Underneath that was a perfect square, so we ended up with a rational number and a rational number. This one's a fraction, the other one's a whole number, but both of them are rational numbers. Okay, so the discriminant can tell us how many solutions we've actually got, and it can tell us whether or not we're going to get any solutions. So here, b squared, 16, minus 4 times a, which is 2, times c, which is 3. 16 minus 24, 8 4 3 is 24, negative 8. Because it's less than 0, we get no solutions. So if we graph this graph, you would see that it doesn't go through the x-axis, because the solution is an x-axis intercept. Here, negative b squared, b squared, don't know where I got the negative from, b squared minus 4ac, 36, minus 4 times negative 1 times negative 9, 36 minus 4 times 1 is positive 4, negative 4 times negative 1 is positive 4, times negative 9 is 36. We end up with 0. If it's 0, we've got one X-intercept. This last one, the discriminant 144 b squared minus 4 times a, which is negative 3, times c, which is 9. 144, 4 3s are 12, positive 12, times 9 is 108, so plus 108. So we get 252. So we say we get 2 irrational solutions. If it was a perfect square, then we would get 2 rational solutions. If it asks for the nature of the solution, the nature is whether it's rational or irrational, or if there's one solution or 2 solutions, but it's basically if it's rational or irrational. Okay, this one here, find the values of a for which the equation 0 equals ax squared plus 3ax plus 1 has 2 solutions. So we've got to have 2 solutions. We know that discriminant has to be greater than 0. So I can say the discriminant is equal to b squared, 3a squared, minus 4 times a times c. That has to be greater than 0. 9a squared minus 4a has to be greater than 0. 9a minus 4 has to be greater than 0. When we've got an inequality with a parabola or a cubic or anything that's not linear, like 5x plus 7, then we've got to sketch it. So when it goes through 0, and if we solve that, we get 4/9. It's a positive parabola, so it's going to look like that. Now we want to know when this graph is positive or above the axis. Well, it's there. So a is less than 1, or a is greater than 4/9. So if a is less than 1, or if a is greater than 4/9, 0, sorry. I'm like, that doesn't make sense. That's a 0, because that there's 0, and that there's 4/9. Now we can look at this graphically. Ax squared plus 3ax plus 1. So a times x squared plus 3a times x plus 1. If we sketch this graph, that's when a equals 1. You can see that we've got 2 solutions, which is above that. If a equals 0, we've got no solutions. Let's try something in between. So let's make it go up my step by 0.1. Okay, if I go up, can you see I've got no solutions at 0.1, no solutions at 0.2, no solutions 0.3, no solutions 0.4. 0.5 I've got 2 solutions, because 0.5, that's 0.44 recurring, and this is 0. So if we go above 0.44, we get 2 solutions. Or if we go, so we go, this is below 0, we've got 2 solutions every time, until we get to 0, we've got no solutions, and then we've got more solutions again when a is greater than 4/9. Okay, last one. I've got this function, and I want to know when I've got 1 solution, no solutions, 2 solutions. So all we want to do is look at the graph of the discriminant. So let's put the discriminant in. We get the discriminant is b squared minus 4a squared minus 4 times a times c, which is 16a squared minus 4 times 2, which is 8, minus 24. If we let it equal 0, we could find out what our x-intercepts are. So we get 16a squared is equal to 24. A squared is equal to 24 on 16, which is 3 on 2. So a is plus or minus root 3 on 2. We can rationalize that. Root 3 on 2 times root 3, root 2 on 2, root 2. So I get root 6 on 2. So they're my x-intercepts, plus or minus root 6 on 2. So here, there's root 6 on 2. There's minus root 6 on 2. If I sketch it, looks like that. Okay, one solution means when it equals 0. So A is plus or minus root 6 on 2. No solutions is when it's negative. So between negative root 6 on 2 and root 6 on 2. When do I get two solutions? That's when it's above the x-axis, i.e. the discriminant's greater than 0. And that is when A is less than negative root 6 on 2, or A is greater than root 6 on 2. So that's when we get two solutions. I'm going to leave it there now, and we can use the discriminant next time to help with solving these equations. Hopefully you understood all that. Let me know in the comments if you've got any questions, and I'll see you again soon.